Okay, as I mentioned before, we're going to continue lecturing here on 16 rat. So if you need to move to see better, move wherever you're best in this room. But we'll continue on here. So we were ending the last talk on this example. So hopefully you started working through that example. If you want, you can take a couple more minutes to kind of finish it up. Again, here we're looking for either the OH minus concentration or the H plus concentration, depending on which one's given to you. And you also want to determine, is it acidic, basic, or neutral? Again, make sure that you do use your exponent button there. And so take another moment or two. Okay, so let's take a look at each of these. And remember, pretty much in each of these cases, we are going to use the relationship that we saw for Kw, which is our ionization of water, which is the concentration of H plus times concentration of OH minus, and it does equal 1 times 10 to the minus 14. Remember that pretty much regardless of which one you're given, it really is the same calculation. So it's 1 times 10 to the minus 14 divided by the other one. So in this case, we're given the H plus concentration. So we're going to be looking for the OH minus, which will be our 1 times 10 to the minus 14 divided by the H plus concentration, 3.4 times 10 to the minus 4. Again, we want to make sure that we use our exponent buttons for both of these guys. So 1 exponent negative 14 divided by 3.4 exponent button negative 4. And it gives us 2.9 times 10 to the minus 11. The units here would be molarity, just like the original units were for the other one. Any questions first off on that calculation? At this point, we basically have two things given to us. We have the H plus concentration, which is the acid part of the solution. And we now have the OH minus concentration, which is the basic part of the solution. So we do want to compare the two numbers. That would be the acid part to the base part to see which one is larger. And in this particular case, the one that is larger is the H plus concentration is larger than the OH minus concentration. So remember that when you do have these negative exponents, the negative is important because the smaller negative exponent is actually the larger number. And that's because if we took 3.4 times 10 to the minus 4, we would go 4 places this way. If we took the other guy, 2.9 times 10 to the minus 11, we're going 11 places this way, putting 0. So it makes it a much smaller number. So in this case, this would be acidic. So the way you could compare is compare the two concentrations. And again, if they're both negative exponents, which they most likely will be, the one that's actually the smaller negative exponent is the larger number. Any questions on that there? Okay. Taking a look at the next one. Once again, we're given the H plus concentration. That means our OH minus concentration will equal 1 times 10 to the minus 14 divided by our H plus. So putting in our numbers here. And using our exponent button again, dividing by 2.6 to the minus 8. We end up with 3.8 times 10 to the minus 7. Once again, the units here would be molarity. Once again, we're going to compare the two concentrations. We have the H plus and we have the OH minus. And in this particular case, it is the OH minus that is larger than the H plus. Again, to the minus 7 would be a larger number as we're only going 7 places to the left and putting zeros. The other one, we're going 8 places to the left and putting zeros. That would mean that this is going to be basic. The base part is larger than the acid part. Questions on that one there? Now, again, if you find yourself with sort of the right front number, but the exponent part is off, That's probably the way you're punching into your calculator. So make sure, again, you use that exponent button. Now we're coming here to the OH minus. Again, it's the same calculation. Our H plus will equal 1 times 10 to the minus 14 divided by the OH minus concentration. So pop it in our numbers here. We end up with here 1.6 times 10 to the minus 6 molar. And upon comparison here, we do see that it is the H plus concentration that is larger to the minus 6 than to the minus 9. And that means that the acid part is larger. So this would be an acidic solution. Any questions on that there? And the last one in the group here, taking our OH minus is equal to 1 times 10 to the minus 14 divided by 8.1 times 10 to the minus 3. Going to get us 1.2 times 10 to the minus 12 molar. In this case, it is actually, oh, that's our H plus, I'm sorry. H plus. In this case, our H plus concentration equals that. There you go. In this case, then the H plus is less than, which would be the other way around. I get that symbol, right? Let's try that again. The H plus concentration is less than the OH minus concentration. There we go. That means that this solution is going to be basic as there's more OH minus than H plus in that solution. Any question on any of those calculations there? Yeah. Let's just do one more here. We'll forget this part of it. So what is the OH minus here? And is it acidic, basic, or neutral? Okay, so here our H plus concentration will equal our KW divided by our H plus concentration. I can get these guys right. So, yep, before today's done. Come here. All right, take 2. They gave us the H plus, so we are looking for the OH minus concentration. There we go. And we have 2.8 times 10 to the minus 5. That's going to give us, looks like a 3.6 times 10 to the minus 10 molar. And that means that if we do compare here, we are going to find that the H plus concentration is larger than the OH minus concentration, which means this thing would also be acidic for sure. Question on how to use KW and the calculation. All right, then we're going to skip the next example, I think. The next thing we're going to talk about is the pH scale, and the pH scale does run from 0 to 7 to 14, and below 7 is acidic, above 7 is basic, and really at 7 there is neutral. That is the point where the OH minus and H plus would equal each other. So it would be a pH of 7. 7 is sort of your middle standard. And as you go from 7 towards 14, you're becoming more basic. And you go the other way, you're becoming more acidic. To calculate the pH is calculated by, it's not negative, that's just from PowerPoint. The pH is equal to minus the log of the H plus concentration. This is another formula where you could substitute in H3O plus. So again, they are basically the same here. Now, when we punch these into our calculators, a couple of things, depending on your calculator as to how you should punch it in. If you have a display calculator, you basically punch it in exactly the way it is, the negative button, the log button, and then your number there using your exponent button. If you have a non-display calculator, this equation and sort of a bunch of other ones that we're going to talk about, you need to actually work backwards. You need to start with the number, then you need to hit the log button, and then you need to hit the negative button at that point. If you're not sure what type of calculator you have, all you have to do is hit log. And if your calculator says log, congratulations, you have a display calculator. If your calculator says error, you have a non-display calculator. So that's the way you can figure it out really quickly. So when you do punch these guys in, you want to make sure using your exponent button and obviously the correct buttons as you go through it. And it is the negative button there. It is not the subtract button. So you want to make sure that you do that correctly. Now, when we do calculate pH, for example, or a value like pH, in terms of significant figures, this is the rule that we typically follow, which is the number of significant figures in the concentration value translates to the number of decimal places in a pH type of calculation. So if your concentration had 3 significant figures, you would go to 3 decimal places, not significant figures. So it is significant figures to decimal places as you go from concentration to pH. And it is opposite, which we'll learn to go the other way from pH back to concentration. It is then decimal places to significant figures. So why don't we try one here? What is the pH, as you got on the bottom there, of a solution that has an H plus concentration of 1 times 10 to the minus 5 molar? So, all right, so take a moment and calculate it to the proper number of digits there. All right, let's take a look at the first one here. So we're going to do a little pH action minus the log of the H plus concentration minus the log of 2.1 times 10 to the minus 5. Again, depending on your calculator, either you're going to do negative log of 2.1 to the minus 5 with your exponent button, or if you have a non-display, you'll start with 2.1 times 10 to the minus 5, hit the log, then hit the negative button. So minus the log of 2.1. That's not it. So minus the log. It's going to give us a pH of 4.68 in this case. Once again, we have 2 significant figures. Gives us 2 decimal places in this case. Any questions on that calculation there? This would then be acidic, as it is less than 7, the pH. Yeah. All right, let's take a look at the next one, which is right there. So 5.9. We have 5.9 to the minus 8. So this is the OH minus is 5.9 times 10 to the minus 8 molar, I believe. 5.9 minus 8. Perfect. Let's get rid of that here. All right. Now, in this particular case, write it higher so it's easier to see. There we go. We actually do not have the H plus given to us, which is what we need to solve for the pH. We have the OH minus, which means we can use KW to get to the H plus concentration as one approach here. So doing that, our H plus concentration would equal 1 times 10 to the minus 14 divided by the OH minus, which is 5.9 times 10 to the minus 8. That gets us about 1.7 times 10 to minus 7, I believe. We now have the actual H plus concentration, which is what we need. So now we could go into here minus the log of 1.7 times 10 to the minus 7. And if we do that, we end up with a pH of 6.77 in this case. pH of 6.77 is not 7, so we'll go with slightly acidic here. Now, if you happen to have not realized that that was not the H plus concentration and you kind of just threw it into this equation, and you got this number minus the log 5.9 to the minus 8 of 7.23. The good news is that is obviously not the pH because that was the OH minus concentration. What you calculated is actually the POH. Yes, the POH uses the OH minus concentration, and the POH is equal to minus the log of the OH minus concentration, which is not necessarily a terrible thing because there actually is a good relationship between pH and POH, where if you take the pH plus the POH, it will equal 14, which means that if you take your POH value and you take 14 minus your POH value, you will get 6.77, which is the actual pH of the solution. So if you happen to do that, you actually calculate something that's real, which is POH, and you can actually use the relationship there to actually get to the pH as well. So this does provide you, as you can see here, an opportunity where you might not need to use KW. You could use the relationship, these couple of relationships there, to allow you to calculate the pH as well. Much like the pH scale measures the amount of free H plus in the solution, the POH measures the amount of free OH minus that's in the solution. This is also where people give the double answer of they calculate the pH, POH, and they go, oh, one's above 7 acidic, one's below 7 is basic, or opposite there, what I just said there, one's above 7 is basic, one's below 7 is acidic, and they end up giving multiple answers. So once again, you do want to make sure you look at just the pH value to determine if it's acidic, basic, or neutral, and that's because the POH scale actually runs opposite of the pH scale. Any questions on that there? So a reminder that the pH changes by 1 for every power of 10 change that you do. So 1 times 10 to the minus 3 is a pH of 3. 1 times 10 to the minus 4 is a pH of 4, and so forth. As the amount of free H plus increases, the solution gets more acidic, so the pH goes down. And vice versa, as the amount of H plus gets lower, that means that the pH gets higher. And that is because, again, as we talked about earlier, the H plus concentration and OH minus concentration runs opposite of each other. So as one goes up, the other goes down. So if you have less H plus, you have more OH minus in the solution, which means it's going to be basic, and obviously vice versa as well. Now, there are a couple of ways that you can measure pH. One is a pH meter, which is on the left there. Basically does a little reaction there, and it measures the free H plus concentration that's floating around in that solution. Most of them work off of voltages, and you calibrate them and say, hey, this voltage is a pH of 7, this one is a pH of 4, and then it can do some math and figure it out. Other ways that you can measure pH is you can use color indicator paper. They use that sometimes like in pools. If you ever take care of a pool, like take a little test strip and you basically match up the color. Same idea here. You dip some of it solution onto the paper. They usually have a key. You try to match up the color to see what the pH may be. Other things that are used that don't tell you the pH is litmus paper, but it does tell you whether or not the solution is acidic or basic. If you have red litmus paper that turns blue, or basically any litmus paper that turns blue, it is basic. And if you have blue litmus paper that turns red, or really anyone that turns red, is acidic. So although litmus paper will not tell you the pH, it will tell you if the solution is acidic or basic, which sometimes is really all you want to know in some cases as well. Clearly, a pH meter would work much better than obviously test paper. Here's the pH scale, and again, where you find some things, pure water, we got milk, we have blood, obviously our acids here, vinegar, lemon juice, our strong base up on top. If you take water that's been sitting out for a while, it's going to be a little bit acidic. It's going to collect some CO2 and make some carbonic acid, which is going to slightly increase the H plus concentration and lower the pH of it. Sometimes people are kind of surprised, like, whoa, it's like a kind of acidic. So sometimes you really need neutral water. Sometimes what people will do is boil it. And when they do boil it, the CO2 becomes less soluble and sort of escapes and brings sort of the pH sort of back up. Now, as we jumped in that last example there definitely is similar scales to pH, and one very popular one is the POH scale, which you do need the OH minus concentration. So really, the names tell you what you need. pH means you need the H plus concentration to calculate it. POH tells you need the OH minus concentration to calculate it. And again, the relationship between the two, the pH plus the POH, is equal to 14. We could add to our list here KW that we saw earlier, which is the H plus and the OH minus concentration, equals 1 times 10 to the minus 14. So you do have a variety of different sort of routes to get to an answer. You could use KW if you wanted to. You can use POH and pH in some cases. So you do have some options as to how to get to the answer. A couple of other important sort of calculations here that we might want to add to our list is if you have the pH, you could get the H plus concentration directly from the pH value, and you take the inverse log of the negative pH. On most people's calculators, to get to the inverse log, that is the second button or the shift button up on the top left of your calculator and the log button. And on most people's calculators, when you do that, it will kind of pop up a 10 and a caret. Then you want to make sure you have the negative pH there. You could also, if you have the POH value, get the OH minus concentration from it. It's the exact same calculation, the inverse log of the minus POH. So once again, when you do that on most people's calculators, it will sort of punch up the 10 and the caret. So these are ways that you can get to the concentrations from the pH values. A reminder, as I mentioned before, the pH scale goes from 0 to 7 to 14, with this being acidic. and this being basic on the pH scale. The pOH scale also runs from 0 to 14, but it is opposite. That is basic, and that is acidic. So I again would highly recommend you avoiding thinking about this guy and always go with the pH, because that's usually the one everybody has in their head. But they do run opposites of each other, just to keep that in mind. Any questions on any of that there? All right, so let's try some here, I think. All right, so for each of these solutions, why don't we calculate? For the first one, let's do the pH, the pOH, and let's also do the OH minus concentration. And is it acidic, basic, or neutral? For the next one, let's do the pH, pOH, H plus concentration, and is it acidic, basic, or neutral? All right, take a couple minutes to see what you come up with here. Okay, let's take a look. So again, based on the formulas we just talked about, you do have a variety of ways to get to things. So basically, we're looking for pretty much everything here. So we're given the H plus, so we're looking for the OH minus. We want the pH, we want the pOH, and so forth. Really, one of the first things you could do is you could either use KW here to get the OH minus. You also could go directly into the pH equation. So that's what I'm going to do. I'm going to go directly into the pH because I do have the H plus concentration given to me. So it's going to be minus the log of the H plus, which gives me minus the log of 3.6 times 10 to the minus 9. And if I do that, minus the log 3.6 to the minus 9 gives me an 8.44 pH. Really, because now I have the pH, I could get to the pOH really simply by using pH plus pOH is equal to 14. That means that the pOH would equal 14 minus our pH value we just calculated. So if we just subtract 14, that's a 5.56 at this point. Take care of that, take care of that. First off, any questions on that there? Now we are also looking for the OH minus concentration. So once again, you could use KW like we did previously to get it. I'm going to use the other method there that we just talked about, which is to use our pOH value. So to use the pOH value, the OH minus will equal the inverse log of the minus pOH. So our negative pOH. So when we do that on your calculator, it should probably pop up a 10 and a caret when you do the inverse log again. Top left corner, shift our second button and log button, which usually has like a 10 and an X above it. That is the button that you want to use. You want to use also your negative button, not your subtract button. So make sure you use your negative button to make it negative 5.56. And if you do that there, going to get us, looks like 2.8 times 10 to the 1, 2, 3, 4, 5, 6 minus 6 molar in this particular case. That takes care of that. Now, at this point, is this acidic, basic, or neutral? Once again, we have multiple values kind of on our page. We want to make sure that we do look at sort of the right value. And again, for most people, you should probably always look at the pH value. So the pH value here is 8.44, which means that it is above 7, which means that this would be basic. Yeah. First off, any questions on any of those sort of approaches? once again, just to show you, if you chose to do KW instead, you could have done that the OH minus is equal to 1 times 10 to the minus 14 divided by 3.6 times 10 to the minus 9. And you will end up there as well. So again, you could go that way if you chose to do so. Any question on any of those numbers or how to punch in your calculator? All right, let's take a look at the next one that we had, which was we had an OH minus concentration of 9.2 times 10 to the minus 9. So in this case, we're going to be looking for everything else. So we're going to look for H plus, pH, POH, and is it acidic, basic, or neutral? In this case, I actually have the OH minus given to me. So once again, I do have the option to either use KW up front to get to the H plus, or I could just go into the POH equation, which is what I'm going to do. So I'm going to go into the POH here. Let's solve for that first. And that would be negative log of 9.2 times 10 to the minus 2. Going to get us a POH of 1.04. At this point here, we then could use the pH plus the POH is equal to 14. And at this point, that means that the pH would equal 14 minus the POH. So 14 minus 1.04. Going to get us a pH of 12.96. Questions on that there? At this point, again, you can use KW, or I'm going to once again do the inverse log of our pH. So our H plus will equal the inverse log of the minus pH. So that's going to be a 10 and a negative 12.96, which is our pH value. So we're going to do inverse log of negative 12.96. That is going to give us a concentration of 1.1 times 10 to the minus 13 molar for our concentration. And once again, if you use KW, that pretty much should be what you got, which is 1.1 times 10 to the minus 13. Once again, here we do want to look at the pH value to determine acidic, basic, or neutral. And in this case, our pH is 12.96. That definitely is above 7, which means it is basic in this case. Once again, this is a case where somebody may look at this value and go, it's basic, but then look at this value and go, it's less than 7. It's acidic, and again, give the wrong answers in this particular case. Any questions on how to do any of those calculations? All right, we were going